In this problem, we have been given a very interesting situation where we have a vessel filled with some liquid and both of them are made to rotate about a vertical axis like this. And as the angular velocity increases, the surface of the liquid starts to curve. In fact, the faster it rotates, the more it curves. Here we need to prove that the surface of the liquid is a paraboloid. That is nothing but the surface of revolution of a parabola. Now, although we have seen this situation many times, it might be a little surprising to us because we assume that all liquid surfaces must remain horizontal. And that is what we need to understand, why they remain horizontal. Well, they remain horizontal because a normal to a horizontal surface is a vertical line, and that is the direction along which gravity acts. So rather than saying that liquid surfaces remain horizontal, let us say liquid surfaces assume a direction the normal to which is aligned with gravity. So if gravity changes its direction, even the liquid surface will also change the direction. But does that mean that just by rotating this little vessel, we have distorted Earth's gravity? Of course not. But we have distorted or changed the local gravity, the gravity within that small vessel. It is pretty much like what they do in space stations. To overcome the weightlessness, they make the space station rotate about itself, thereby creating centrifugal force on the occupants who get forced outward, and the outer wall becomes their ground and the centrifugal force becomes their gravity. So that is the analogy we'll be using to understand this problem. The analogy of orbiting space station where artificial gravity is created by rotation. Of course, keep in mind that we are not in an orbiting space station where people are feeling weightless, but we are very much on Earth. So gravity is there. So in addition to the existing one, we are going to have this artificial gravity produced because of the centrifugal force. So the two will get added and their resultant will be the effective gravity. And based on the direction of that effective gravity, the liquid surface will assume its orientation. So that the effective gravity becomes its normal. Let us understand this with help of a vector diagram. In this diagram, here we have Earth's gravity, the usual 9.8 meters per second square gravitational acceleration. And in addition to that, we have the centrifugal acceleration acting horizontally like this. And these two accelerations get added up to give this resultant of the effective gravity. So this effective gravity acts in this direction. And then the liquid senses this effective gravity and assumes a direction perpendicular to that. So the tangent to the liquid surface will be perpendicular to this effective gravity. So the liquid surface will be along this direction. Let us now try to quantify this orientation assumed by the liquid surface. And we can do that in terms of this angle theta over here made by the liquid surface with the horizontal. And the slope of the line over here will be tan of theta. That tan theta can be seen in this triangle also. And the opposite side to theta is r omega square, the centrifugal acceleration. The adjacent side is g. So tan theta can be expressed as the centrifugal acceleration divided by gravitational acceleration, r omega square upon g. But since both g and omega are constant in this case, we can write tan theta is directly proportional to r. So slope is directly proportional to the radius. But radius or the radial direction is nothing but the x-axis in our chosen coordinate frame. So we are having the cross-sectional curve of this surface so that its slope is proportional to x coordinate, a property of a parabola. And therefore this sectional curve must be a parabola and the surface must be a paraboloid. Of course, we can do this using calculus also. Instead of writing tan theta as the slope, let's write dy by dx is directly proportional to x, and then dy by dx will be kx, where k is a constant, and integration would give us y is equal to kx square plus c, which is the equation of a parabola.